Here's a brief overview of the Tracer's mission.
Tracers consists of two satellites flying in tandem in low Earth orbit, designed to understand the effects of magnetic reconnection in deep space on Earth's atmosphere.
Magnetic reconnection is an explosive feature of energy that occurs when Earth's magnetosphere, a protective bubble shielding our planet from cosmic radiation, is impacted by the solar wind. Highly energized particles hurtling towards Earth at over 1 million miles per hour. This causes powerful streams of particles from the sun to penetrate Earth's atmosphere, which can negatively impact our power grids, communication systems, and satellites.
Society today is becoming increasingly dependent on technology, so we need to understand the risks that the sun and its influences pose to our technological infrastructure in order to keep society safe and functioning.
At the University of Iowa, we built and designed the spacecraft's instruments to do something that has never been done before. Attempt to measure magnetic reconnection more than 3,000 times. Together, the two spacecraft will create a data set that will be key in helping scientists understand how the sun's activity can affect our planet and create space weather.
Earth in near-Earth space is a big, complicated, time-varying system. Tracers is one of the sort of early demonstrations of how you can use multi-spacecraft technology to get a picture of how things are changing, how things are moving, how things are evolving.
So not only will it get a global picture of reconnection in the magnetosphere, but it's also going to be able to statistically study how reconnection depends on the state of the solar wind. This is going to really help us understand how to predict space weather in the magnetosphere.
T-minus 15. T-minus 10. 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff. Go SpaceX, go Tracers.
Vehicle is pitching downrange.
At T plus 30 seconds and counting, Falcon 9 has successfully lifted off from Space Launch Complex 4E. After clearing the tower, we now tilt or gimbal the engines to initiate a roll maneuver, which you may notice here in that Stage 1 camera view.
Falcon 9 power and telemetry are nominal.
Now this enables the vehicle's antennas to stay in the best position for communicating with the ground. Coming up next, the vehicle will pass through max Q, which is the point of maximum aerodynamic pressure.
Vehicle is supersonic.
And the engines will throttle down ahead of this to reduce
M1D chamber pressure is nominal.
To reduce load.
Max Q.
And there's that call out for max Q. Now the Merlin engines are back at power and we're out of the throttle bucket. From here on, even though velocity is rapidly increasing, the atmospheric density is decreasing, resulting in less loads on Falcon 9. Now the rocket typically needs to go about 17,500 miles per hour horizontally in order to avoid gravity pulling it back down to Earth. Now coming up shortly, we're going to hear callouts for a series of events happening in quick succession. This will be MECO, followed by stage separation, then the stage 1 flip, followed by second engine start 1, and then the boost back burn. We should be hearing all of these callouts here in just about 20 seconds from now.
Main engine cutoff.
Stage separation confirmed.
MVAC startup.
Stage 1 boost back startup.
And there we heard callouts for the successful main engine cutoff, stage separation, saw that stage 1 flip, second engine start 1, and the boost back burn. Coming up next will be the fairing deployment on the second stage. Both halves of the fairing flying today are flight proven, with one flying for its 14th time and the other for its second time. They'll be picked up today by our West Coast fairing recovery vessel.
Fairing separation confirmed.
And we heard fairing separation is confirmed. So the boost back burn on the first stage is still ongoing, and we expect shutdown shortly.
Stage 1 boost back shutdown.
And there was confirmation of boost back burn shutdown.
We're currently at T plus 3 minutes and 40 seconds into today's mission. And coming up next, we'll hear the call out for the first stage entry burn on the Falcon 9 first stage coming up in about 3 minutes from now. And you'll be able to follow along with that relight with the graphics along the bottom of your screen. Now, Falcon 9 is the first orbital class rocket capable of reflight. Reusability allows SpaceX to refly the most expensive parts of the launch vehicle, which in turn drives down the cost of going to space. It's key to lowering the cost of spaceflight, which enables more investment in critical scientific research. And that makes missions like today's possible for more organizations and more often. Now, the first stage that is supporting today's mission is flying for its 16th time. It previously supported NASA Crew 7, CRS-29, PACE, Transporter 10, Transporter 13, EarthCare, NROL 186, and 8 separate Starlink missions. But while this booster is on its 16th trip to space, we're working towards qualifying our fleet of Falcon boosters and fairings to support 40 missions each. And for those following along, we're currently at 29 flights of a single Falcon booster, which is absolutely phenomenal. Increasing Falcon's flight count provides valuable information on repeated reuse, which is a critical element for making life multiplanetary.
Now, as a reminder, the 9 Merlin engines on Falcon's first stage are optimized for sea level, and they can achieve around 190,000 pounds of thrust during ascent and descent. Now, compare that to the single MVAC engine you see on your screen. This achieves around 220,500 pounds of thrust in a vacuum state. During entry burn, Falcon 9 will decelerate by firing its Merlin engines, but the vehicle is still moving really fast. As Zach mentioned, this causes the vehicle to fly through Merlin's exhaust gases, and this deposits the layer of soot on the vehicle's surface, giving Falcon 9 that flight-proven look.
Now, coming up next, we should be hearing that call out for the entry burn of the Falcon 9 first stage in just about 10 seconds from now.
Stage 1 entry burn startup.
There's that confirmation of entry burn startup. If you take a look in the lower left-hand corner of your screen, you can see the engine status. 3 of those 9 Merlin 1D engines will fire for the entry burn.
Stage 1 entry burn shutdown.
That's a short burn. Entry burn has shut down. So coming up next will be the landing burn. And this is the final burn to slow the vehicle down even more and make that precise landing. Great view of Falcon 9 first stage coming back.
Stage 1 FTS is saved.
And we utilize both the Merlin engines throughout these various return re-entry burns, as well as the grid fins to stabilize the booster.
Stage 1 transonic. Stage 1 landing burn.
Stage 2 terminal guidance.
Stage 1 landing leg deployed. Stage 1 landing confirmed.
Stage 2 FTS is saved.
And a beautiful landing
And
for
back
this
shut down.
booster, marking the 16th flight of this first stage.
Yeah, absolutely beautiful landing here, Amanda. Now, in the meantime, Falcon 9's second stage is continuing its first burn of the mission, and we expect it to shut down just after T plus 8 minutes. And as a reminder, the MVAC engine on the second stage will be completing 4 separate burns today
Nominal orbit insertion.
before we deploy all spacecraft. We also just heard that call out for nominal orbital insertion.
So at this point, the second stage is going to embark on a coast phase, and that will last about 40 minutes before the MVAC engine relights for a second time at the T plus 51 and 8 second mark. So we're going to take a pause here and leave you with some space jams, and we'll see you back here at T plus 49 minutes for second engine start 2.
Tracers SV1 separation confirmed.
There we heard confirmation of successful deployment of the second Tracers satellite. Beautiful live view on your screen. As a reminder, these twin satellites will measure magnetic reconnection a record-breaking 3,000 times, helping scientists better understand and prepare for the effects of the sun on Earth.